And now we have the next part of our discussion on wave motion. We have superposition of waves. In the previous videos, we only considered the situation wherein you have one medium, one wave. One wave traveling through the medium. But it's also possible to have more than one wave traveling in the same medium. And when you have more than one wave traveling in the same medium, there's the possibility that the waves will overlap. When waves overlap, the wave functions are added together for those points of overlap. This is referred to as superposition of waves. Say you have medium, line of particles lying on the x-axis. You have one wave, y1, heading towards positive x direction. And then you have y2, the second wave, heading towards negative x direction. Since they are traveling in the same medium and heading in the opposite direction, eventually the two waves will overlap. For the points wherein you have overlap of the two waves, you have y1 plus y2. The wave functions are added together for those points of overlap. You have y1, wave 1, y2, wave 2. When there is overlap, at the points of overlap, you have y net, the net or resultant wave at the point of overlap. Y net is equal to y1 plus y2. Superposition of waves. The result of the superposition, y net, is referred to as the interference of the two waves. And depending on the overlap, the interference might lead to an increase in the disturbance experienced by the medium, particularly at the points of overlap, or a decrease in the disturbance experienced by the medium. If there is an increase in the disturbance experienced by the medium, you have constructive interference. The y1 plus y2 for the points of overlap leads to an increase in the disturbance experienced by the medium. On the other hand, you have destructive interference if the overlap y1 plus y2 leads to a decrease in the disturbance experienced by the object. And if this decrease leads to cancellation of the disturbance, y1 plus y2 not only leads to a decrease in the disturbance, but y1 plus y2 is equal to 0, there is total destructive interference. Constructive interference, total destructive interference leads to the phenomenon that we refer to as wave amplification and cancellation. So you might want to consider this as reading assignment. Read up on the concept of wave amplification and cancellation via wave superposition to get a more complete picture of superposition of waves. It's important to note that overlapping or intersecting waves do not in any way alter each other's propagation. Each wave continues on its way as if the other wave does not exist. It is the medium at the point of overlap or points of overlap that is affected by the superposition of the waves. The medium will behave according to y net. Y net is equal to y1 plus y2. One interesting result of the superposition of waves is the formation of what we refer to as standing waves. Standing waves are also referred to as stationary waves. A standing wave is formed when you have two identical waves moving in opposite direction and these two waves overlap. The result of the overlap is a standing wave. Say we have two waves, y1 and y2. Say y1 is equal to ym sine of kx minus omega t. You have a sine wave heading in the positive x direction with zero phase constant. y2 is identical to y1 except that y2 is heading towards negative x direction. y2 is equal to ym sine kx plus omega t. Two identical waves, y1 and y2, heading in opposite directions. If we allow these two waves, y1 and y2, to overlap, we have y net is equal to y1 plus y2. Expanding the equation using the identity of sin cos cosine, and then simplifying, we get y net is equal to 2ym sine kx cosine omega t. This gives us the equation for the wave function of a standing wave. The wave function of a standing wave is given by y of xt is equal to ysw sine kx cosine omega t. Ysw is the amplitude of the standing waves and it is equal to 2ym, twice the amplitude of the original two waves that overlapped. Speaking of the two waves, looking at say y1 is equal to ym sine of kx minus omega t. If you look at the equation, x and t are in the same parentheses. We can interpret this as there is motion along the x-axis. On the other hand, if we look at our equation, the wave function rather, if we look at the wave function for a standing wave, x and t are separate. They are no longer inside the same parentheses. We may interpret this as there is motion, but not along the x-axis. As far as the x-axis is concerned, the wave is stationary. You have a standing wave. One characteristic of a standing wave is the formation of segments in the resulting behavior of the medium. You have the medium, again, series of points or line of points lying on the x-axis. If there is standing wave in the medium, you will notice segments being formed in the medium. You have one segment, and then another segment, and then another segment, and another segment, and each segment is simply vibrating back and forth. The endpoints of a segment is referred to as the node of a standing wave. So node, 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 and node, and the nodes the particles of the medium are always at the equilibrium position. These particles are stationary, they are not being disturbed from the equilibrium position. Midpoint between two nodes, or the middle of the segment, you have the antinode of the standing wave. So antinode, 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 and antinode. It is the particles at the antinode that are capable of reaching the maximum disturbance from equilibrium position. So again, the medium is basically divided into segments when you have a standing wave in the medium, and each segment is vibrating back and forth. There is motion, but the motion is not along the x-axis. As far as the x-axis is concerned, you have a stationary wave. You have a standing wave. Now, the standing wave is still periodic. One whole wavelength is still basically a sine function. One whole wave is comprised of two segments. So, two segments will make up one wave. The length of two segments, that's the wavelength of the wave. So, two segments make up one wavelength, one lambda. As such, a segment is referred to as a half wave, while half a segment is referred to as a quarter wave. And as already mentioned, the endpoints of a segment are called nodes, while the midpoint between two nodes, the midpoint of a segment, is referred to as an antinode. The nodes are always at the equilibrium position. It's always y is equal to 0 for the nodes, whereas the antinodes are capable of reaching the maximum displacement from equilibrium position, capable of reaching y is equal to ysw, the amplitude of the standing wave. And that's it for now. That's it for our discussion on superposition of waves. In the next video, we'll continue our discussion. In the next video, we'll take a look at the concept of standing wave in a string. So once again, that's it for now, and thank you for watching.